All right, good morning, everyone. Thank you for joining. Hope you've had a good conference so far. We're here. My name is Daniel Choi. I'm a product manager for AWS Private CA, and with me is...
Hi, I'm Devi Gupta. I'm a senior software engineer on the Private CA team.
And today we're going to be talking about securing and increasing the productivity of your mobile workforce by using AWS with mobile device management or MDM solutions. So you get started here. So yesterday we happily announced the launch of public preview of AWS Private CA or Certificate Authority connector for SCEP. Basically what this allows you to do is use AWS Private CA, a managed cloud CA solution where every private key is HSM backed, and use it with your mobile device management solution to enroll mobile devices, whether it is phones, tablets, or laptops. By using AWS Private CA, you get to reduce your PKI operational costs and complexity. It is a managed solution. And not only that, the SCEP service that we launched is also managed, giving you everything you need. The endpoint, the challenge passwords, all of that, without you having to do anything to build out the underlying infrastructure or maintenance of it. And lastly, the connector for SCEP is part of a portfolio of connectors that AWS Private CA offers. This means it allows you to have a single Private CA solution for your enterprise, whether it is for securing your AWS resources, users and machines in Active Directory, workloads in Kubernetes, and now mobile devices. So before we jump into that, just to give you a high level of what we're talking about today, just to ground everyone on the topic, we're going to talk about certificates, certificate authorities, then we'll jump right into connector for SCEP, why use mobile device management solutions, and how does the connector actually work, as well as providing a quick demo. Then we'll wrap up overview of the other connectors within the Private CA connector family, and a quick couple slides on AWS Private CA itself, just so you get a better understanding of what it is. So just to ground, like I said, just to ground folks, why do you need certificates? Really two main use cases, right? Encrypting data in transit and identifying and authenticating endpoints. When you talk about encrypting data in transit, we're very familiar with public certificates, right? This is what websites like Amazon.com gets so that your browser can trust that when you visit it, it's a legitimate, trusted website. Right? If you've ever gone to a website where their certificate expired, you'll see that big error in your browser that says, hey, are you sure you want to proceed? Right? And similar to public certificates that are used to secure communication with websites and web applications, private certificates secure and identify things within your enterprise, like devices, users, machines, containers, and so forth. So, Divi, can you tell us a little bit about the certificate services at AWS?
Definitely. So AWS has a number of certificate services that are offered that can fit your organization's needs. The first one is ACM. So ACM is Amazon Certificate Manager. Amazon Certificate Manager will let you easily provision, manage, and deploy public and private certificates. What that means is you can hook up ACM with your AWS Private CA, which we'll talk about next, and it'll let you issue private certificates as well. And once you've issued a certificate through ACM, you can actually use it to deploy certificates out to other AWS integrating partners, such as API Gateway and ALB, Amazon Load Balancer. Next, you have AWS Private CA. So AWS Private CA is what this talk is going to be all about. It's a highly available CA service. It lets you set up a PKI hierarchy without the ongoing cost, maintenance, specialized staff that's usually required to have your own PKI system. And then finally, we have AWS Signer. This is code signing. So this allows organizations to really check where does their code packages come from and make sure it's from a trusted, verified source. A very common use case for this we see in our customers is with containers. So again, the talk today is really going to be focused on AWS Private CA. So before we talk about AWS Private CA, though, I want to talk a little bit about the challenges of not using AWS Private CA if you're self-managing your certificate authorities. So first of all, PKI is complex. A story I like to tell on this one is there's customers that we've talked to. A customer anecdote we have is they came to us and said before we were using AWS Private CA, they were not sure where all their CAs were. They talked to their PKI team, and their PKI team also told them that there's CAs that are kind of scattered throughout the organization, and some of those CAs were root CAs that were actually issuing and entity certificates. So if you manage your own PKI, you might know that's usually against best practice. Root CA should be issuing subordinate CA certificates. And so they decided, hey, we're going to stop this practice, and they decided to self-manage and figure out how to do that. They went on a 18-month campaign across the organization to figure out where all their CAs were, kind of audit what they were issuing, and they thought they had solved the problem 18 months later. 6 months after that, so we're 24 months in now, they found out actually the problem wasn't solved. Their root CAs, there were still CAs that they didn't know about, and their root CAs were still issuing entity certificates. This is all just to illustrate that even with the best intentions, your PKI team inside your organization can have a hard time managing and operating a PKI of their own. Next one, there's a lot of manual processes. Everything I just described sounded very manual. There's also things like ceremonies that go into managing your own CA. A ceremony is where you would have to reissue a CA certificate or maybe rotate your CA certificate. And it's a very difficult thing to do. You end up having a lot of PKI experts in your organization all get in a room, do a bunch of auditing, go through a bunch of manual steps. All of this very difficult to automate, and it ends up slowing down your organization. Next one, it doesn't really facilitate automation. So if you're managing your own CA, you don't have APIs usually, you don't have an SDK that you can just call. It ends up slowing down your developers. And like I said, ceremonies are a great example of something that just cannot be automated. Finally, there's cost. This is a big one that customers talk about. Managing your own CA can be very, very expensive. An example that I like to give on this one is that it is about HSM. So if you have your own CA, an HSM is a hardware security module that you need to store your private key securely. If you go and buy your own HSM, you're looking at $20,000, $25,000, $30,000 for a single HSM. Now, if your organization wants redundancy, double or triple that. Now, if you want high availability, maybe double, triple that. So you're looking at possibly tens of thousands of dollars in just infrastructure costs. Now you have your staff. Now you have your specialized team. All this stuff adds up very quickly. We had a customer tell us that they were self-managing their own HSM. They actually spent $25,000, $50,000 on HSMs. Their organization tried to do a firmware update. When they did the firmware update, they found out that they accidentally bricked their HSM. Because again, it's very difficult to self-manage these things. They bricked their HSM. Next thing they know, they were out a bunch of money and they had to start all over, which goes to show you some of the challenges that come with traditional CAs. But now we're going to talk a little bit about private CA and how it's a little bit different. Dan will walk us through that.
Yeah, thanks, Divi. So how is private CA different than what we just call traditional CAs? Well, first, it's a managed solution where we take the undifferentiated heavy lifting of managing PKI, operating PKI off of your hands, right? So we're talking all that underlying infrastructure, databases, servers, the HSMs, all that gone. We do it for you, right? So, and then in addition to that, as Divi said, we help you be secure. Every private key is generated in an HSM, signing happens in the HSM, and they're not exportable. So no worries that the private key leaks and you have a CA compromise. Divi talked about, traditional CAs typically don't have your APIs. Well, we are API forward service, issuing certificates, revoking them. That's all doable through automation. And then we also have high scalability, right? So if you run into a place where your traditional CA is starting to run out of capacity, issuance rate, you're going to have to go in and invest in that hardware and infrastructure. Again, here, we support everything from IoT devices for like the Matter Smart Home standard, where we issue tens of millions of certificates, to enterprise use cases, right? Active Directory, Kubernetes, and AWS Private CA issues on average about more than 1.5 million certificates a day, including internal certificates as well. That means over 500 million certificates a year, including internal certificates. And then lastly, yes, you can set up a CA, yes, you can set up your PKI, but I want to use it with these different use cases, whether it's service meshes or whether it is with Active Directory, or whether it's with my mobile device management solution. Well, AWS Private CA is integrated with a lot of solutions and services within AWS, making it easier for you to do things like use IAM with certificates for even workloads that aren't even in AWS. So let's jump into the main topic of our talk today, which is AWS Private CA Connector for SCEP. So what does it really do? At the end of the day, it allows you to use AWS Private CA with SCEP-compatible applications, clients, endpoints. Typically, that means mobile device management solutions. I'm going to take one step back and talk about the connectors overview, which is what are connectors? Right? AWS Private CA, I just told you, is a managed solution, scales, great high availability. But connectors allow you to use Private CA in environments that have a natural, native established certificate distribution solution. That's a mouthful. What does that mean? Basically, you can think about things like Active Directory, right? It has auto enrollment. It just works. You put a user, a group, and user machine into a group, they get a certificate. It renews by itself. Kubernetes, if you're using that, there's a Cert Manager add-on. It's a free open source add-on for certificate lifecycle management. It does a fantastic job of making sure your certificates get to the right places and also stays valid. And so really by using connectors, you can use AWS Private CA as a single CA solution for a variety of your enterprise use cases. Now back to what I was saying a moment ago. What is Connector for SCEP? Basically, you can use it with SCEP-compatible endpoints, clients, applications. Usually this means mobile device management solutions. And SCEP stands for Simple Certificate Enrollment Protocol, just in case you weren't aware of that. And that is what a lot of MDM solutions have adopted for enrolling certificates. So I'm going to talk a little bit about MDMs, right? So we talked about improving productivity, being able to use it. What is an MDM? Why should you even consider it? We'll give you a high-level rundown of it, but basically allows you, your enterprise administrators, to control and enforce policies on mobile devices. So whether it's corporate issued or you bring your own device like I do for work, they can set rules such as, hey, you have to have a passcode, it has to be 8 digits long, you can't have certain apps on it, things like that. It also provides some information back to you to say, hey, are any devices in a state that is less secure? Maybe it's in a weird IP location, things like that. So it provides that kind of information as well. And then lastly, for that example where I bring my own device to work, I want a clear separation between my work data and my personal data. I don't need Amazon data mingling with the social media apps that I'm using, right? And bring your own device is actually the most common use case that we've heard, right? And why would that be? So first thing we found out or learned is it's up to 34% higher productivity when you allow your employees to use mobile devices, right? So that means, hey, I get to be on block because I have a question or I need an approval, and that can happen on the go. In addition to that, you can save up to $350 per employee compared to issuing a corporate owned device, right? So going out and buying a mobile device and giving it to your employee, compared to that, you can save a little bit of money. So higher productivity, lower cost, that's one of the biggest reasons why we see bring your own device as a major use case. So Divi, do you want to tell us a little bit about the connector itself?
Yeah, definitely. So like Dan said, we're excited to be talking about the connector for SCEP today. So when you're creating a connector for SCEP, you really have two choices. You can create two types. The first one is going to be a general purpose connector. So let's talk about that first. A general purpose connector is designed to work with endpoints that support SCEP. Now there's a couple of use cases here. The first one is mobile device management. So mobile device management means that you can use the general purpose connector with MDMs such as Jamf Pro or AirWatch, and other SCEP compliant MDMs. You can use it with network gear, routers, printers, whatever other gear that you have that is SCEP compliant. And the last thing you need to know is that the challenge passwords that you create are managed by AWS. What does that mean? So a challenge password in AWS, so a challenge password is a SCEP concept, and it's kind of the security layer that exists within SCEP. So a SCEP server will create a challenge password, it'll distribute, and then you distribute that out to your clients and your trusted MDMs, And once that distribution happens, your SCEP clients and MDMs will actually be able to make requests to your SCEP endpoint that the connector for SCEP will create for you, and it'll know that, okay, this person knows the password, so they're authorized to issue a certificate. So that's how you do challenge password management. And then the other type is the type for the type for Microsoft Intune. Now this type is designed to work with, as you probably guessed, Microsoft Intune, and that connector type is going to have challenge passwords managed in Microsoft Intune. So what that means is you're not doing the management within AWS. Now in this connector type, you're managing those challenge passwords within Intune. So every single request that's made to issue a new certificate has its own unique challenge password that Intune will create, send to your client, and the client will make a unique request with a unique challenge password. So that management is done for you in Microsoft Intune. So next, we'll talk a little bit about what the architecture looks like there. Like, what does it look like to actually use a MDM with the connector for SCEP? Now, one thing I want to call out is using the connector for SCEP does not require you to use an MDM. That's just a very popular use case that we see with customers. So here we have a MDM solution. This could be Intune, it could be AirWatch, it could be Jamf Pro. And you have your AWS Private CA that you've set up within AWS. And you have the connector for SCEP that you've also set up. Once you set those things up, the next step is you have a mobile device that your organization is managing. This could be an iOS device, it could be an Android device, a laptop, iPad, whatever your organization's using. And the mobile device configuration that you create will actually get pushed to your mobile device from the MDM. Now, what is a configuration profile that I just mentioned? A configuration profile is something that you set up in your MDM. It's going to contain an endpoint, it's going to contain maybe a challenge password, and what your certificate looks like. So I can say I want a specific extension in my certificate, or I want a specific subject in my certificate. All those things are set up in my MDM and pushed to my mobile device. Once my mobile device has that, it'll connect with the endpoint for connector for SCEP, and it'll request a certificate. Once it requests a certificate, the connector for SCEP will go to AWS Private CA, it'll grab a certificate, get it issued, and send it back to your mobile device. There you have it. It's pretty simple. Now you have a mobile device that is enrolled in your MDM and has a certificate issued through AWS Private CA. Now, all of this sounds pretty simple, and it is, and we're going to show you in a 5-step demo here. And so it's going to be a series of videos. We're just going to talk through it real quick. First, we have the step where we're going to create a CA. After we create a CA, we'll show you how easy it is to create a general purpose connector. And after that, we'll talk about Microsoft Intune a little bit. We'll show you how to make a connector for that. And then we'll also talk about how to create configuration profiles within Microsoft Intune. And then finally, we'll talk about enrolling a device. So let's get started with the demos.
We'll be creating a connector for SCEP. The first step in creating a connector for SCEP is to create a private CA. So let's go ahead and do that. Here you have the private CA console. I will go ahead and click the Create a Private CA button. Here you have a wizard that pops up with some options that we're going to go through. You have mode options. So this is asking you to pick between general purpose and short-lived certificate for your 2 CA modes. For the purposes of a connector for SCEP, we recommend using general purpose. So I'm going to go ahead and click that. Now under CA type options, we have a root and a subordinate option. I'm going to go ahead and stick with root for the purposes of this demo. And so I'm going to click that. And now under subject, we have many fields. A lot of these are optional. But for the common name of your CA, I'm going to go ahead and say, let's call it recording demo. Great. So now we have a common name for our CA. And now we have some options for key algorithm. The key algorithm of your CA can be RSA 2048, RSA 4096, EC P256, and EC P384. So I'm going to go ahead and click RSA 2048. This is the most widely adopted algorithm, so we're going to use that for the sake of this demo. But if you have other compliance needs or other key algorithm needs, you can go ahead and click any of the other ones as well. They will all work with the connector for SCEP. Great, so now we have certificate revocation options. Here, you can select CRL. And if you selected the CRL option, you'll provide it with a S3 bucket name, and the console will actually create that S3 bucket for you. And CRLs will then be generated and delivered to that S3 bucket. And so clients can pull it down from there. And then if you need OCSV, we can also there's also an option for OCSV. For now, I'm going to go ahead and uncheck both of these because I will go forward without replication for the demo. Here you have tags. You can go ahead and tag your CA. So I guess we can do that. We'll say for the key, we can say recording, and the value can be demo. Here, this is CA permissions. This basically says that I'm giving ACM access to renew certificates that are requested by this account. I'm going to go ahead and keep this checked. And then here we have pricing. This is just acknowledging that the private CA service has pricing associated with it. So I'm going to click that and acknowledge that. I'm going to hit create CA. And awesome, now I have a CA that is in the pending certificate state and was created successfully. Now, this CA cannot be used to actually issue certificates quite yet. That can only be done when the CA is in the active state. So right now the CA is in the pending certificate state. So what we're going to do is activate it by clicking actions here, going to install CA certificate. And what this will do is it will actually issue a CA certificate off of your CA and then import it back into your CA to activate your CA. So then your CA certificate will be part of your CA, and you'll have an active CA that you can then use to issue more certificates. So here your CA certificate has a validity period. And so you can select that here, but we'll leave it as a default. And then there's a signature algorithm that you can pick from. I'm going to go ahead and leave it as SHA-256 RSA. I'm going to hit confirm and install. And there you have it. Now you have a CA certificate that you can view right here that was issued for you and imported back into your CA. And you have the CA in the active state. So you can actually issue certificates off of the CA that you can then go and use. So awesome. What I'm going to do next is I will go ahead and export this CA certificate.pem, and I will save that for later because we'll need that in then some of the next steps when we're setting up our connector for SCEP. So as you can see, we only took a few minutes to set up a whole new, brand new CA that is highly secure, available, and managed.
Awesome. So as you can see, setting up a CA was very quick and easy. It only took a few minutes. And one thing I want to call out about the CA, not only is it highly scalable and completely managed for you, this CA has its private key backed in an HSM. What that means is that we created a private key when we created the CA, and that private key is created in an HSM, and any signing operations that occur will happen in that HSM. So if you remember that customer anecdote from before where it's really hard to manage expensive HSMs, all of that is done for you here. And on top of that, that private key cannot be exported from the private CA service. So that means your private key is always secure, no one can get to it. All right, so we just talked about creating a CA. Next, we'll talk about what we're launching today, which is the connector for SCEP, and how easy it is to create one. So let's take a look at that demo.
In the previous step, we created a CA. In this step, we're going to create a connector for SCEP. So we are now in the connector for SCEP console. On the left, we have some links to other connectors and to the private CA console as well. One thing to note is the connector for SCEP is currently in preview. That means changes might be made to the service, and we don't recommend using the preview for production workloads. So here I'm going to click the Create Connector button. And we have some options here. I'm going to go ahead and tag or name my connector here. I'll call it recording demo connector. And then here we have connector types. Now there's two types of connectors that you can create when you create a connector for SCEP. If you pick the general purpose connector type, this type is designed to work with endpoints and applications that support SCEP. SCEP is widely adopted for mobile device enrollment and networking equipment, so this will work for many different types of MDMs. If you're using Microsoft Intune, you'll use the Microsoft Intune type of the private CA connector for SCEP. So to start off with, let's use the general purpose type. So I went ahead and selected that. And here I can go pick my CA. So I'm going to go ahead and find the CA that we created earlier, called the recording demo CA. Select that. And then here it's gonna ask me, do I want the console to create a challenge password for me? So when I hit create connector here, a couple of things are going to happen. First, it'll share my PCA with the connector for SCEP service. This allows the connector to issue certificates from your private CA to SCEP endpoints and applications. When you create connectors outside of the console, such as through the CLI or API, you'll need to create the AWS ramp share prior to creating a connector. But when you do it through the console, this is done for you. So when I click the create connector button, the console will take care of that step. Next, it's going to create the connector. Creating the connector involves creating an endpoint that you can later use to actually make SCEP requests, and your clients can use to make SCEP requests. And another thing the console will do for you is it'll create a challenge password for you. As a managed service, all this happens on your behalf to simplify setting up SCEP for your PCA. So a challenge password here is one of those steps. Challenge passwords are used to authenticate a request before issuing a certificate from your CA. A challenge password is a static password and needs to be distributed out to your clients and MDMs for them to be able to issue certificates against your CA. Great, so I'm going to go ahead and hit create connector. And all the steps that I just mentioned before are happening. The CA is being shared with the connector for SCEP service, and the endpoint is being created. And you'll see here now we have a active general purpose type connector with an endpoint and a challenge password. So let's take a look at this challenge password. Here I can click it and click view password. One thing to note is that you can actually use IAM policies to lock down who can view that challenge password. So here I have IAM permissions, and so I can view the password right here. Go ahead and close this. Another thing you can do from the console is you can create a new password. Just create a new one, and I can delete an old one by selecting the delete button and typing delete and delete. So here I've just rotated my challenge password, and I can do that without a hard cutover. All I have to do is create a new password, update all my SCEP applications and clients to use that new password, and delete the old one. That way you can avoid downtime during challenge password rotation. Great, so here we've created a general purpose connector for SCEP.
So as you can see, it's pretty easy to create a connector for SCEP. That was about a 3-minute video. And so in the 3 minutes before this, we created a CA. And in the next 3 minutes, we set up a connector for SCEP. So altogether, 5 to 6 minutes to set up a highly secure, highly managed, scalable CA service that you can use with connector for SCEP. And at this point, if you're using the general purpose connector type, you're pretty much ready to go. You can use the general purpose connector type to actually work with your MDMs like AirWatch and Jamf Pro. So next, we'll talk about the next connector type, which is if you're using Microsoft Intune. We'll show you how to make that, and we'll show you how to set that up.
In the previous step, we created a general purpose connector. The connector for SCEP also has a Microsoft Intune type. So let's go ahead and get started and create a Microsoft Intune type. I'm going to hit create connector. Here I'll call this Microsoft Intune connector type. For the connector type, I'll select Microsoft Intune. Now with this type of connector, we'll have to go to Microsoft Intune and actually do a few steps to allow the connector for SCEP to be able to access Microsoft Intune. So let's go ahead and go to Intune here. So I'm in the Azure portal. And in Microsoft Azure, I just searched for app registrations and ended up at this page. Now, under app registrations, I'm going to go ahead and click new registration. Here, I'll call this testing. And I can leave the other values as default. So what I've done here is I've actually created an application within Azure. So now I'm looking at this application, and we'll see that the connector for SCEP console is asking for an application ID and a directory ID. So let's copy paste those values. Application ID, I'm going to copy that. And directory ID. I'm going to go ahead and copy that as well. Great. Now I can proceed as in the same fashion I did with the general purpose connector, where here I will search for my CA. I'll select it. And notice how the console is mentioning that the CA has been shared with the connector for SCEP service already, because I used the same CA in the previous step when I created the general purpose connector. But that's okay. It'll just get reshared. So I selected my CA, and I'm going to hit create connector. And here it's going to go through very similar steps as last time, where it's going to go ahead and create an endpoint. And one big difference, though, is here we will not be self-managing these challenge passwords. Instead, and as the console says, when using this connector type, you manage the challenge passwords using Microsoft Intune. And so what we've done here is we've created a Microsoft Intune connector type. And now we can go ahead and move on to the next step, which is setting up access in Azure.
As you can see, again, we created another connector type. This was, if you're using Microsoft Intune, you'll create this connector type. And this was another really easy step. Showed you how to set up that connector. The next step here will show you how to actually grant access. So your connector for SCEP needs to be able to talk to your Microsoft Intune tenant, and we'll show you how to do that in the next demo.
Next, we're going to make sure that Microsoft Intune has access set up correctly so the connector for SCEP can actually access Microsoft Intune. So let's go ahead over to Azure. Here we will see the app registration that I just created called testing. I can head over to certificates and secrets, federated credentials, and click the add credential button. Here I'm going to select other issuer, and I can go ahead and copy the values that the connector gave us. So here we have a value for issuer, subject, and audience. So I'm going to click issuer and paste that into the issuer. Subject identifier, paste that in. And here I'm going to copy the audience and add it right here. I can name this testing and hit add. Great. So now my connector for SCEP has access to Microsoft Intune. Now I'm going to go ahead and configure the permissions that the connector for SCEP has on my Intune configuration. So here I'll go to API permissions, and I'll be able to add those specific permissions that the connector for SCEP will use. So I'm going to click add a permission and go and click Intune. And now I can go to application permissions and search for SCEP and click add permissions. I'll add a second permission here by clicking add a permission again, Microsoft Graph this time, application permissions, searching for application and application read. Add permissions. And then one last button here, I'm going to grant admin consent. Great. So I pretty easily just set up my connector for SCEP to have access to my Intune. Next, I need to create a configuration profile that can be used by Intune to actually push SCEP certificates and SCEP trusted user profiles to my devices. So I'm going to head over to Microsoft Intune. And here I went to devices and configuration. Here I'm actually going to create two configuration profiles. The first one is going to be for, I have a Windows machine that's set up that I'm going to use as my device that I'm enrolling to Intune. So I'll go ahead and select that first. And then here the profile type will be trusted certificate. So what this means is that a trusted certificate is a certificate that ends up in a device's trust store. So for us, we're going to use our root CA's CA certificate that we created earlier as the trusted certificate. So I'll go ahead and click create. I'll call this trusted cert. Hit next. And here I need to upload it. So I'll actually upload it by just taking the certificate that I downloaded earlier, the CA certificate from my CA, and changing the .pem to .cert. Open that up, hit next. Say that all devices that are Windows machines that enroll to my Intune will get this get the certificate in the trust store. So I selected all devices, hit next, and I hit create. Refresh, and we see it there. Great, so my next one is going to be same thing, Windows 8 and above, and this time it'll be a SCEP certificate profile. And this is what's going to actually cause Intune to push a configuration profile to your device, and your device will then go and make a request against the connector for SCEP to actually issue a certificate. So we'll call this SCEP certificate. We'll say it's a device type of certificate. Here we can call it, this is the subject, we'll say testing. And we will look at the other options there. We have options for subject alternative name. We'll leave this as default. You can configure the validity period of your certificate. We'll leave that as 1 year. For the key storage provider, we'll go ahead and say this option right here. For key usage, we can select both digital signature and key encipherment. Key size, we'll go with 2048. Again, these are all demo values. You can configure this however you wish. And the hash algorithm will go with SHA-2. Root certificate, we'll say this is the trusted certificate, which represents our CA certificate. Hit OK. For extended key usage, or EKU, I'll go ahead and say any purpose. And here, this is the renewal threshold. What this means is that if your certificate will be renewed when 20% of its lifetime remains, so we'll leave that as default. And this right here, it's asking for the URL of your SCEP server. In our case, that's the connector for SCEP's URL. So go ahead and grab your unique URL right here and paste it in. Hit next, next, oh, previous. We gotta add all devices. So this is saying any Windows machine, again, that enrolls will get this SCEP certificate issued. Hit next and create. If we refresh, we should see it here. Great, so we see SCEP certificate and trusted certificate.
So here you saw how you set up access for the connector for SCEP to be able to access your Microsoft Intune. Another set of just pretty easy steps that goes, this is all in our documentation as well. Next up, we'll show you the actual exciting step, which is seeing a device enroll in Microsoft Intune and seeing those certificates being pushed to it. So let's watch that demo.
In the previous step, we created a connector for SCEP. In this step, we'll actually enroll a device. So I have set up a Windows machine here, and I downloaded a company portal. And after I downloaded company portal, I simply signed in using my Microsoft Intune credentials that were unique to my tenant. And so once I had signed in using my credentials, that was just my username and password, I am going through this wizard now, which will actually enroll this Windows machine to Microsoft Intune. So I'm going through this wizard, hit next, and it's saying I am now enrolled. So I'll hit done. I can see this device is enrolled. And if I go to settings and sync, what I'm hoping to do here is actually pull down the two configuration profiles that we created. It said the sync was successful. What that means now is if I look in my trust store on this machine, I should see my CA certificate. So let's check for that. So I'll search for computer certificates here, hit yes, and go to trusted root certification. And let's see, recording demo. This right here is my CA certificate that I had uploaded to Microsoft Intune and has now been pulled onto this machine. So that's pretty cool. I just created a Windows machine, enrolled it to Intune, and now my CA certificate that I had issued with AWS Private CA is now on this machine. And every Windows machine that enrolls from now on out will have that automatic behavior as well. The next thing I should see is when I go to personal certificates, here I should see that the SCEP certificate that I had requested was actually issued, and it looks like it was. So if I open this up, this right here is my certificate that I had set up with a configuration profile in Microsoft Intune. So what happened here is this Windows machine enrolled to Microsoft Intune, and then it automatically knew to go and ask the connector for SCEP for a new certificate. So it hit that endpoint that the connector for SCEP had set up, and a certificate was issued by your AWS Private CA. So this right here shows you how easy it is to set up your AWS Private CA with a connector for SCEP that can then be used to enroll your machines and devices.
So there you have it. You created a private CA, you created a connector for SCEP, and then you were able to enroll a device in Microsoft Intune. It's a pretty simple process, and next, now that we've talked about this, we'll talk a little bit more about the concept of connectors, and Dan's going to tell you a little bit about that.
Yeah, thanks, Divi. That was a great set of demo videos. I hope that helps you all understand how quick and easy it is, at least for the PKI steps, to get to setting it up and being ready to then configure your MDM, SCEP compatible applications, clients. But as I mentioned before, Connector for SCEP is just one of 3 connectors that we have. We're going to wrap this session up just talking a little bit about those connectors and then a little bit about Private CA. So one of the other connectors we have is Connector for Active Directory, very similar to Connector for SCEP. It's for identity certificates. If you think about what do we use private certificates within Active Directory for, one of the main ones we hear is securing your domain with LDAP-S or secure LDAP or LDAP over SSL, right? Without it, all your domain communications is happening over plain text. Not great. The other thing is to enroll your users and machines, right? Providing them an identity by installing a private certificate onto them. Most common use case here is I want this laptop to enter the office and get onto the Wi-Fi so that I don't have to have them constantly using the Wi-Fi password or having to rotate it out and letting everyone know. And less common of a use case is encrypting emails and files. If you use certificates, you can sign it to encrypt those objects. But like I said, not as common. And just to let you know, the Connector for Active Directory works with 2 types of Active Directory, if you will. One is the AWS Managed Microsoft Active Directory. This is an offering offered by AWS Directory Services. This is a managed Active Directory. They do the patching, upgrading. They recently went through a campaign where they upgraded everyone to 2019. And then self-managed, right? So whether you're hosting it on premises or if you're hosting it in the cloud, like on EC2, you can use the Connect for Active Directory for both use cases. And so just a quick diagram on how it works. On the right side, you'll see this is your on-premises setup. You have Active Directory, you have AD domain joined objects, right? And you're like, I have a private CA. I want to use it with my Active Directory to enroll my AD objects. Well, first thing you actually have to do is connect it to the AWS cloud. That happens by using the AWS Directory Service product, and now your on-prem Active Directory is in the cloud in a way where AD-aware applications, such as private CA workspaces, other things, can actually communicate with your Active Directory. This is when you would say, okay, connect me to it. That's when you use the connector for Active Directory. Now, private CA is a trusted CA within Active Directory. It can actually communicate and do LDAP queries. And all you have to really do at this point is configure your group policy object. Right? Go in and say, hey, domain computers, going forward, go point to the endpoint that Private CA connector provided. And once you update that GPO, it reaches out. We do a bunch of things at this point. The connector communicates with the Active Directory to say, hey, is this requester actually allowed to get certificates? Are they in your directory, whether it's a user or a machine? In addition to that, it's going to communicate back and forth with that object. What certificates do you have? What certificates do you need? And after that communication is over, it goes up to your AWS Private CA, grabs the certificates, and shoots it back to the object. And all of this happens through your VPC. Nothing goes over the public internet, so it stays within your network. Divi, you want to talk a little bit about Kubernetes?
I definitely do. So the connector for Kubernetes is another connector like Dan talked about. So one thing I want to just start off by saying is the connector for Kubernetes it's a big space for our customers. 2 out of 3 containers that are running in the cloud right now run in AWS. What that means is if you're running on-prem or if you're running in EKS or you're using Cert Manager already, this is a tool that's very useful for you, and we expect customers to continue growing in that space. So let's talk about what that looks like in terms of an architecture diagram. So let's say you have your own Kubernetes cluster. Again, it could be EKS or it could be your own self-managed one. Maybe you're running a service mesh. This could be Istio. We see that a lot in customers. And you have your own microservices that are running within Istio. So a lot of organizations already have this set up where they're using Cert Manager. So Cert Manager is commonly referred to as the de facto tool for certificate management within Kubernetes. Now, Cert Manager is an open source plugin. A lot of organizations are already using it. And so what we've built with the connector for Kubernetes is just a plugin for that. So whenever your microservices need certificates, it'll reach out to Cert Manager. And then the connector for Kubernetes is right there working with Cert Manager. And Cert Manager will ask the connector for Kubernetes for a certificate, and the connector for Kubernetes will take it from there. The connector will reach out to AWS Private CA, it'll issue a certificate for you, send it back to your connector, send it back to Cert Manager, and then your microservices in Istio will have the certificates it needs. This is a very common infrastructure setup that we see. A lot of organizations already have Cert Manager. This is just an add-on now that works with it. So there's no need to replace anything that you already have. Next up, there's a lot of options you have for TLS termination and where to use TLS in a Kubernetes cluster. So let's say this is your Kubernetes cluster. You may have an application load balancer in purple, or you may have an ingress controller right on the edge of the EKS cluster, or you may have pods that are running within that cluster that you can do TLS termination at. So some of the options there, you can terminate at that load balancer, or you can terminate at the ingress controller, and that's what we see commonly done. And we have termination at the pod as well. And then finally, you can use the connector for SCEP the connector for Kubernetes to do secure communication between pods as well. And so we talked a little bit about connectors now. Dan walked us through that. We talked about the connector for AD. We talked about the connector for SCEP. We talked about the connector for Kubernetes. Next, let's talk a little bit about AWS Private CA. So AWS Private CA, you may be asking, when do I use it? Like, what are the common use cases that we see? So let's walk through them. A common use case that we see is using AWS resources outside of AWS and within AWS. So we talked a little bit about ACM earlier. So customers will often issue a certificate and use it with an ALB, or they'll use it with API Gateway. So Private CA will work with ACM, and ACM kind of opens the door to a bunch of other integrations. Next, you have IoT devices. Now, this is something we see customers use all the time. There are millions of certificates being used right now through AWS Private CA that are used on IoT devices. Now, this can be Matter compliant. So if your organization is Matter compliant, it's important to call out that AWS Private CA is currently the only cloud provider with a Private CA solution that is fully Matter compliant. And so we have a lot of customers using Private CA for those use cases. We also have them using it for stuff like AWS IoT Core. So if you're using any of those things, then Private CA fits your use case. Next, service meshes, containers. We kind of went through this in detail in the last slide, but this is the connector for Kubernetes. This is if you're using a service mesh. Again, 2 out of 3 containers in AWS. 2 out of 3 containers running on the cloud run in AWS, so we expect this space to keep growing. If you're using service meshes and containers, AWS Private CA can hook you up with that, with certificates. Next, identity. What I really think of with identity is I am anywhere. So let's say you're an organization that has a workload that's running outside of AWS, and you have a hybrid infrastructure. So you have some resources within AWS. So you can use I am anywhere to establish identity. So your workloads will establish identity using certificates and private CA, and then you can use I am anywhere to actually exchange that identity for AWS credentials. And that's how your hybrid infrastructure works, where your non-AWS workloads will be able to reach into AWS and use those AWS resources. So we talked a little bit about use cases, like when do you use private CA? But let's talk a little bit also about the benefits of using private CA. So first of all, we've talked about this a lot. It is a secure, managed, scalable service. So we talked a little bit about some customer anecdotes before, where customers didn't know maybe where their CAs were, or were having a hard time understanding where to issue certificates from, whether it's the root CA or the entity CA. So with private CA, we make a lot of these things easy. Through the console, through high availability, a lot of these things are made easier for you. We also support developer agility. This is automation. So customers can create private CA through CloudFormation, through CDK. They can create it through, they can automate things through the console or APIs or SDKs. They have a lot of different options to actually speed up the agility of their work. Next, you can create root CAs and complete hierarchies within private CA. So you don't have to manage anything outside of it. Your root CA can be in private CA, your subordinates, your whole hierarchy can all be done within private CA. And then also you have the ability to actually customize certificates. So in a certificate, you may want to customize what kind of extensions are in there, the subject, all the different things in there. You can do that via API pass-through. So API pass-through is a mechanism in private CA where you can actually pass in parameters through the API, and it'll affect what your end certificate looks like. You can also do it through CSR pass-through. So you can put extensions in your CSR that get copied over to your end entity certificate. You can also do customization through preset templates that we give you. And this is really nice because you can control access to those templates through IAM, and you can just have predefined templates that customers can use to define what their end certificate looks like. Finally, manage your CA centrally. So no running around trying to find where all the CAs are in your organization, like the customer story we told earlier. You have one console. In private CA, you go to one console, you can see all of your CAs. You can call one API, the List Certificate Authorities API, see all of your CAs. So there's no more losing your CAs, you can see it all in one easy pane of glass. And finally, pay-as-you-go pricing. So when you create a CA, you will pay for ongoing maintenance and costs, but if you don't issue any certificates that month, there will be no charge for certificates that month. So it's very much pay-as-you-go pricing. So we talked a little bit about the benefits and the use cases for private CA. Now, Dan, do you want to tell us a little bit more about securing your private CA?
Sure, I'll wrap up with security because we are at a security conference. Right, we've kind of spoken a lot about this. HSMs, they're a big part of private CA and the security that we offer. IAM policies for access control, right? So you put all your CAs into an account, you can share it. When you share it, you can allow that other account to only issue certificates. Don't touch my CA, don't create a CA, don't delete a CA, right? Not only that, what's kind of cool is you can also use it as a two-party requirement, right? What I mean is, hey, I have someone in my company who can create CAs. I have someone who can actually issue certificates. Those two people are not the same. So if I want to issue a brand new CA certificate or CA, deploy it, I actually need both of them together for us to actually get a new CA deployed. That way you're not creating CAs without really knowing. Managed CRL and OCSP, revocation is an important part of PKI, and we provide you with both managed services. And then lastly, I want to know what's happening in my CA. You get the audit logs. You also get a free generated audit report. Every certificate issued, whether it's revoked, expired, or still valid, you get that all in a single report, which makes it easy to do two things. One, provide it to your compliance auditor. Two, you have an incident, every single cert is there for you to look through. I'm not going to read this slide off to you, but private CA supports compliance for data privacy and protection. You can learn more by going to the website at the bottom to see which ones we comply with, but basically we want to be able to support you and have you use us in highly regulated industries and fields, environments. And lastly, here's our takeaways, right? So you got this fully managed CA, highly available, real secure. It's a cloud-based, API forward CA solution. The portfolio of connectors allow you to use it for a variety of enterprise use cases. Think about agility, how quickly you can set up a CA for use for your dev environments, for your production, whatever your use case is, and the ability to customize certificates, as Divi mentioned. We can issue certificates from IoT to TLS to identity, all the way down to mobile driver's licenses, right? And then lastly, we make it easy. Amazon, if you're using containers, Amazon EKS, Amazon ECS even provides its own service mesh if you're using it between services. You flip a switch, you're using private CA, you have TLS. We continue to integrate to make it easier for you wherever you are to use private certificates. And just thank you. Thank you for joining us this morning. My name is Dan, this is Divi, and please complete the survey, and we'll be right over here on the side if you want to talk. But
Thank you,
appreciate
everyone.
it.